this math solution. Today we're talking about the New Year problem. Okay, so let's go ahead and dive into the solution for this problem. So if you remember, we had the ball, and it is 12 meters off the ground, and it's going to start to fall 10 seconds before midnight. Okay, and we want it to hit the bottom exactly at midnight. And to drop this ball, it's actually wrapped. It's on a string that's wrapped around a drum. Okay, and this drum rotates by an operator who's got this big cranking handle. Okay, and he cranks it to slowly drop the ball. And we wanted to know, okay, what was the tangential velocity that the operator should crank such that the ball touches the ground exactly at midnight. So let's go ahead. Let's dive into this. And I think the best place to start is actually just looking at the ball. Okay? So we've got the ball, we've got distance, and we've got time, right? So with distance and time, we can actually calculate what V2 should be. And then we can work our way backwards. Okay? So V2 here is also the same here. Okay? It's just the rate that the ball is actually dropping. And so if we do this, if we go 12 meters, okay, the distance that it has to travel, over 10 seconds, okay, then we're going to end up with 1.2 meters per second. Pretty simple, right? So this is our V1, or sorry, V2. Okay, so this is the velocity that the ball has to drop at. Okay, so we want the tangential velocity of the operator, which is V1. So that's really what we need to find now. We have V2, okay? And now we can use this equation to solve for V1, okay? But we still need to figure out what D1 and D2 are. Well, we can take a look here. So D1 is going to be half of the diameter, right? It's the radius for these two circles. Okay, so D1 is going to equal a half of this 2 meters. It's going to equal 2 meters over 2, which is just 1 meter. And D2, similarly, is going to equal 1 meter over 2, right? Which is going to equal 0.5 meters. Okay. So now we can rearrange this to solve for V1. So V1, okay, the velocity that the operator needs to crank, okay, the tangential velocity, is equal to V2, which is 1.2 meters per second, okay, multiplied by D2, all right, and we said D2 was a half, multiplied by D2. Is D2 a half? No, sorry, I got that backwards. D1 is a half. Let's see, D1. Let's see here. D2 is this one, which is a half. Oh no, okay, that's right. Okay, V2 times D2. Okay, 0.5. Divided by the 1, this is going to give us 0.6. 0.6 meters a second. Okay. All right. So, we're saying that it has to crank at 0.6 meters per second. Tangential velocity. Okay, but that actually doesn't seem right to me. I think it should be the other way around. Yeah, so this equation, there's something wrong with this equation here. So that's going to have to be D2, and this will have to be V1. Because what should have happened is this should have been 1 over 0.25, and then have gotten 2.4 meters per second. Okay. Yeah. So that's what it should be. It should be 2.4 meters per second. We just want to make a small correction on this equation. It should be V2 times D1 equals V1 times D2. But there we go. That is our final answer there. So 2.4 meters per second is the tangential velocity that the operator should spin at. So I hope you enjoyed this math problem, and I'll see you in the next one.